So LAZ files can't be brought into ArcGIS Pro directly. They have their own lidar compression format called ZLAZ, but LAZ is a little bit more common. So if you download an LAZ, you're going to need to use the Convert LAS tool to do the conversion. So it's just a matter of locating that file, specifying a target folder. There we are, finally finding the lidar folder. And then you've got a number of different options here. You can rearrange the points. I generally recommend that you don't do that. You can define an input coordinate system, which I'm initially going to not do here. And you're going to see that this conversion actually fails because even though I've downloaded this from the national map, for whatever reason, the projection information wasn't fully embedded in the file. Now, projection information should be embedded in LiDAR files, but oftentimes it is not. But you can define that with this tool, or you can later define it with the define projection tool. And then the question is what projection, what coordinates are your data in? And so to find the answer to that, you're going to want to dig in the metadata. This is going to be highly dependent. In this case, this is not the right metadata. This is the product metadata that we want. And as I scroll down to the bottom, you're going to see that the vertical datum is NavD88, which is very common. The units are meters. But the horizontal datum is a little unusual. This is going to be in NAD83 CONUS albers, which you see down here. That's fairly unusual. Most of the time you would find this stuff in UTM. So we're going to have to dig for that. So we go into the projected coordinate systems in continental and North America, and we're going to find NAD83 2011 contiguous USA albers and select that as the horizontal datum. And then we also have to specify the vertical datum. So we go into a gravity model, and we're going to find the NavD88 with heights in meters. So lots of options there. And we're going to hit run. Here we get one more failed message because even though I got a message before, the message I'm getting here is that the LAS file already exists from the previous failed conversion. So I'm just going to delete that, and then we can run this again, and this run completes. And then we can take that file that we just had, the newly created LAS file, and we can drag it in there. You'll notice that there's a PRJ file in there. That's a projection file that's been added to it. That's an unconventional way to add projection information to a LiDAR file. That's what's called a sidecar file. So it's existing alongside. It has the same file name, but a different extension, that PRJ. So that's unusual. Usually that would get embedded straight into the LiDAR file, but this is the way Arc does it, which does mean that if you try to load that LiDAR file into a different GIS software, it will similarly not have projection information. This isn't a huge problem for Cloud Compare, which doesn't really care that much about projections. It just cares about the coordinates themselves, but it would matter if you're using something like QGIS to look at the point cloud. Here at the end, I've kind of panned around and zoomed a little bit, and what I have done is change the symbolization to classification. So LiDAR data often will come to you pre-classified in a limited way, usually ground and non-ground. Ground will get a code of 2, and then everything else would get a code of typically 1 if it's been run through a classifier and left unassigned. So the gray stuff that you're seeing here is a bunch of anything that's not ground remains gray. The ground gets flagged as this brown color, a 2 in the internal data. And then there's also some noise, which is flagged as 7. So that same sort of big smear of data that we saw earlier is all 7, and then you can see sort of a smattering of noise points identified by whatever the algorithm was. So key points here are that LAZ files aren't directly importable into ArcGIS Pro. You have to convert them to an LAS first. If you're using the NOAA interface or some other interfaces, you can actually choose to download an LAS file right from the get-go, which is often a good idea. But if you haven't, if you're downloading from the national map, you have to get an LAZ, and so you'll need to do that conversion. So convert LAS is your step. Most LiDAR data should come with a projection attached, so it's unusual here that this little section around campus, the Binghamton campus, did not have projection information. But it's not so unusual, and so being familiar with how to look in the metadata and repair that projection by applying it either when you're doing the conversion or later using the define projection tool is always a good idea. Other tools are capable of doing the conversions and repairing projections, but this is how you would do it in ArcGIS. Thanks.